The atomic theory is one of the most important concepts that form the foundation of chemistry and physics. Throughout history, scientists have tried to understand the structure of matter, leading to the emergence and gradual development of various models of atomic theory. This theory is a scientific journey that started with the idea of the atom as the smallest indivisible unit and extended to modern quantum mechanics. The roots of atomic theory go back to ancient Greek philosophy. In the 5th century BCE, Greek philosopher Democritus suggested that all matter is composed of small, indivisible particles called atomos. This idea was based on philosophical reasoning rather than scientific evidence and remained a theoretical notion for many centuries. The concept of the atom was placed on scientific foundations in the 19th century by John Dalton. In 1703, Dalton proposed the modern atomic theory, stating, "All matter is made up of atoms. Atoms of a given element are identical in mass and properties. Chemical reactions involve the rearrangement of atoms." Dalton's theory allowed for the quantitative study of chemical reactions and significantly contributed to the development of chemistry as a science. In 1897, J.J. Thomson discovered the existence of negatively charged particles within the atom, electrons. This discovery challenged the idea that atoms were indivisible. Thomson proposed that electrons were embedded in a positively charged substance, creating what became known as the plum pudding model of the atom. However, this model had significant weaknesses. In 1911, Ernest Rutherford conducted his famous gold foil experiment and proposed a new model of the atom. He showed that the atom has a tiny, dense, positively charged nucleus at its center, around which electrons orbit. This model provided a more accurate depiction of atomic structure. Niels Bohr and the Bohr model. In 1913, Niels Bohr improved upon Rutherford's model by introducing the Bohr model. According to this model, electrons revolve around the nucleus at specific energy levels. Electrons absorb or emit energy when they move between these levels. The Bohr model successfully explained the spectral lines of hydrogen, but had limitations when applied to more complex atoms. Between the 1920s and 1930s, scientists like Erwin Schrödinger, Werner Heisenberg, and Max Born developed new atomic models based on quantum mechanics. These models propose that the position of electrons cannot be precisely determined. Instead, they are described by probability waves. Electrons exist in regions called orbitals, rather than fixed paths. This quantum model forms the basis of our current understanding of atomic structure and better explains the behavior of multi-atomic systems. The development of atomic theory is one of the greatest achievements in the history of science. Thanks to this progress, we have gained a deep understanding of matter at the microscopic level, leading to advances in technology, medicine, and material science. Atomic theory is a cornerstone of modern physics, chemistry, and material science, and continues to be fundamental to scientific discovery.